Hello, how are you doing? Okay, so we'll get started in about a couple minutes. Happy Valentine's Day.
Recording.
Okay, so if you are ready, you can log into Canvas. We are gonna go over our syllabus in about a minute. Okay. And turn on caption. Okay, so we'll go ahead and get started. Welcome to CIS11. Today is our first day in assembly programming. This course is transferable to CSU and UC. My name is Casey Nguyen. I know if you haven't had my class before, this is the first time. I've been teaching at Moreno Valley College for over close to 5 years now. I teach in programming and cybersecurity. So in this class, we're going to learn about assembly programming. So I'm going to go over the course content. If you have questions, you can type it into the chat or you can unmute and ask the questions. So the first part of today's session, we are going to go over the course requirements, syllabus, and information. Then we are going to move into the lecture and the assignment of the course for Unit 1. So for this course on Tuesday, we're going to mostly address the lecture and we're going to do some assignment together. Starting next week on Thursday, we are going to do some programming. This week, mainly, we're going to address some of the number system, how to do the conversion. So I want to make sure that we're on the same page. Did someone have a question? Sierra, did you have a question?
Yeah, I did have a question. Can you hear me?
Yes.
Okay. Are we going to be using the simulators?
Yes. And I will
So-
talk about that shortly.
Oh, okay.
Give me 1 second. Any other questions? Okay. So in this class, we are going, here's our Canvas page. You will see the first module, which contains all the information about the course. Here's the course information. And this is the same information that will be listed in your syllabus. So we are going to meet on Zoom weekly on Tuesday and Thursday. And I do record the session, so I will push that on YouTube and also link that back to your Canvas for the assignment and the lab and the lecture. So that will be on the video page for each of the week and also on your assignment page and the lab page. The Zoom information you can find here. I think I did send that out also, and you can find that on the syllabus. The requirement of this course is you need to have advisory, which is some programming coming into the class. It helps if you know a little bit of programming like C++ from CIS5. Okay. And then for my contact information, you can find that here. I do hold office hours. The only thing that I recently changed is I updated my office hours. It went from 1 p.m. Now it will be 12 to 2. And then everything else stays the same. But if you can't make these hours, you can send me an email and we can make arrangement on meeting outside of my office hours. We can do it via Zoom, or if you want to stop by Moreno Valley College campus, my office is there. I'm on the park side near the park or the soccer field, and my office is in PSC 21. Okay. And then I do turn on Zoom. So I met with several students today. And so if you want to meet on Zoom, we can do that. So next we're going to talk about syllabus. So on the module, you can find your syllabus located here. Okay. And for the syllabus, let me scroll back up. I haven't updated the latest document with the latest office hours, but I will do that as soon as we finish. So in this class, we are going to go over microprocessor architecture. We're going to cover RISC. We are going to learn assembly programming language, and the language that we're going to learn is LC3. So LC3 is taught in many universities like Cal State San Bernardino, and at a lot of different universities. So when you transfer to the university, if you take the next level class, you should be familiar with it. And LC3 is close to ARM. There are some instructions that are the same, but there are some slightly different. It's very much like different syntax that you're gonna see different. So comparing like C++ to Java, but in this case, assembly is more on a low level. So we're going to learn how to write programs in assembly. We are going to use a simulator, and I'll tell you where you can find a simulator to download or use an online simulator. We are going to look at machine instructions. Okay. A lot of the things that we do in assembly, unlike C++ or Java, which is high level programming language, assembly is a little bit different where we work directly with the machine instructions. But first, in this week, we are going to cover numerical computation. You have to know how to look at the instructions comparable to hexadecimal value or binary. You have to see what the computer is seeing. So that's what we're going to address starting this week. We talked about Zoom session. So Tuesday, we are going to cover lecture and assignments. And then on Thursday, starting next week, we're going to cover, okay. Thank you. We're going to cover the programming side. So here's your course content. For this class, we're going to look at microprocessor. So your microprocessor, how it sees the processes, how it store data, how we can access data. We're going to work mostly with registers, and registers is like, think of it like a container where we're going to store some data or instructions, and we're going to look at memory addresses. So in this class, we're going to look at the architecture and how data is organized, accessed, and used. Then we're going to look at von Neumann machine or the model. We're going to see how the computer is created and how the microprocessor plays an important role in computing. Then we're going to look at the control unit, which is part of your microprocessor. We're going to look at instruction, how it's fetched, how it's decoded and executed. So when you write something in C++, when your compiler compile your code, how that's being done at the low level. So we're going to compare that to C or C++. Then we're going to go into assembly language and its format. So in that, we're going to cover instruction sets, how the machine understand what is needed to be executed. how to be able to manipulate your data and work with I/O, your input output, like mouse, keyboard, data storage, like your disk. And then looking at instruction formats, how it's going to be structured. So when you write your code, there's a specific way that you would be able to code in assembly. Then some part of this week and throughout the semester, we're going to address your word size, which is 16 bits. And it could be vary from architecture to architecture. So as we are using this architecture, that's going to be a 16-bit word size, very similar to your Intel 86. But in other architecture, like your ARM64, in some of your Android system, like your smartphone, you would see that your word size is 64-bit. So it varies from one processor to another, and we will talk about that. How your data is stored in certain sizes. And as you know, when you work with downloads, upload, different type of files, you already dealt with like how your data is contained. But we're going to look at how it's used and stored, especially in the memory. Then we are going, for this week, we are going to address data representation as numerical value. Your computer is a calculator. So it is just going to add, and we're going to talk about why. And we're going to look at different number system and like the base 10, which is your normal counting mathematical number. Then you have your binaries and hexadecimal and octal. So we're going to address different number system. And we're going to look at fixed and floating points. Also, starting this week, we're going to talk about 2's complement, how the computer actually used 2 complement to subtract values. There is not really a subtraction. It's just using the 2's complement, which is addition, to be able to represent the subtraction as we see as humans. Okay, so we'll talk about that. And then how we are going to represent non-numerical data, also ASCII value, encoding systems, and also your graphical data. And then to be able to use linking to import in some of the library, and that's toward more the end of the semester. So as you know that we can use files that already been created by developers as libraries, and we can include those files. As you know, in C++ we use include, or in other languages we would use import. So in assembly, we're going to talk about how we're going to be able to link files together to build a program. And we're also going to talk about address mode. So when you look at your simulator, how it looks like with your memory addresses. And then how we define data and structure data. So for those of you who took data structure in C++ or Java, right, or Python, you would tie it back to how is that compared to high level and low level. And how we would use modularization to be able to build a program that is structured for data access. In LC3, we don't use too much flags. There are some flags that are being used compared to other assembly language, but we'll talk about flags and overall for your application. Do you have any questions for me? Okay, so here's your learning outcome. By the end of this class, you should be able to analyze, interpret your assembly language programs, right? And be able to see it from a numerical level as well. And compare that to high level programming like C, okay? And we're gonna write and execute your program, and this is where our labs and our projects are gonna play a big role. So every week, I'm gonna walk you through your assembly programming line by line and explain why we're doing certain things. So you will be more comfortable in writing and running your program or simulating your program. and how you, when you look at your simulator, how that is being used mathematically, when we look at a program, how the computer sees numerical value. And we would tie the program into how that can be used in business or organizations. Okay. So as we know, I know that this class transferred to Cal State's and UC's. Some of the UC teaches assembly language with ARM or in other languages, but ultimately you're going to see the instructions are very similar or the same. So once you learn LC3, which is taught in like, University of Texas, a lot of the big school, Cornell, etc., you would see it's going to be really an easy transition. It's like learning C++ and then be able to write in C. So there's a lot of similarity. This is the book I'm using. You can download your textbook there. It's a PDF. Or you can purchase the book online. It is a little pricey if you do the purchase. Yes, it is an old book, but in the organizational and the architecture area, computing hasn't really changed since its original model. There are progress in how we create newer processor, but the architecture itself, the category, it's going to fall into subcategories, and I'll explain to you what those are. And so when you're looking at something for Android or iOS, many of the newer modern systems uses RISC, and we'll learn about that today. And then you have the Intel-based system. So the textbook, I recommend that you read the chapters. It's important that you do so you can have a better understanding of what we're going to be discussing. And you're going to get the most out of the class if you do the pre-class reading. Okay. And for your assignments, when you attend the session, I will walk you through your assignments. And if you're unable to attend, you can watch the video and be able to do your assignments. I do take late work every week that is late. It's going to be 10% deducted from your earned score. And I do take late work up to 3 weeks. Okay. Your class activities include your assignment and lab, but for your assignment, that's going to be weighted into the category for assignment and participation. I use Canvas so you can submit everything by Sunday, 11:59 p.m. In the case, if you have some challenges, if you need help, please reach out to me and we can go through the assignment together. We can do that via Zoom, or you can stop by my office. I'll be happy to do that. For your course project, this is going to be given toward week 9. So you will have from week 9 through week 16 to work on your project. I will require group work, and we will talk about how we're going to be signing up for our project groups and planning out the process in executing your project for your course. Now, for your project, I will ask that you would put it on GitHub. So we will talk about how you can use GitHub if you're new to that, and be able to create your repo and publish your code. It's important that you maintain that because it's going to help your career as you would have GitHub repo for your ePortfolio. I do not take late project, as I give about 6 weeks or 7 weeks for you to be able to create your project, and you can utilize to build your project. So now, if you have emergency circumstances, please let me know. But as I need to submit my grade, and they only give me a few days to do that. And I read all project code line by line. So it takes me a little bit to go through all your projects. So therefore, I don't accept late project. For your quiz, you will have a few quizzes in this class. It will be given to you via Canvas. You have 3 attempts for your quiz. The highest score will be recorded. I normally do like a little pre-quiz game where if you use that, it's going to help you prepare for the quiz. and you can earn a gift card if you have the highest score. And so you will see that in the upcoming weeks. There is no midterm exam. I will have a final exam, which covers all the concept that we go over in this course. Some part is programming, some part is going to be just concept based. Okay, and final exam is going to be via Canvas, and you will need to use Lockdown Browser to do that. So we'll talk about how you can install Lockdown Browser. There's going to be a specific link for the exam through Lockdown, so you cannot just use any link to install and access the exam. And I will not allow late exam, as I will turn it on at the beginning of the week, and you have approximately 4 days to be able to take your exam. So, and I will cover final review toward the end. So if you attend the session, you will be able to review for your exam with me, and exam is multiple choice. Any question?
Oh, we good.
Okay. So for grading, here's your category. Quizzes is going to be 10%. Assignment is going to be 35%, and that's including your participation. Your lab is going to be 20% of your grade. Project is going to be 15% of your grade. And for the project, I do weigh in your group assessment. So you are going to assess each other. So if one person did all the project, right, that person can grade the other team members, and I do read the review for that. So that will be weighted in for your project grade. And project is broken into multiple parts, and they are designed to help you build your portfolio along with uploading your code for submission and documentation. For your quizzes, that's going to be 10%, and your exam is going to be 20% of your grade. So altogether, that's 100%. I use the traditional college requirement for your grade. So there are no pluses in your grade or no minuses. So here's your breakdown for the range of your grade. Any question? So for student conduct, by college policy, right? Just be respectful to each other and be mindful that we are all different. And if you have any issues, there is student grievance policy for complaints. But if you have issues, please address that with me, and I will be able to identify the problem and hopefully help you resolve the problem. For attendance and participation, I expect that you attend lecture and lab. For this particular class, it's essential that you attend lab in case you have questions, because assembly is going to be a little different if you have never done it before. It seems very foreign to a lot of students at first, but once you go through the lab, you're going to have a better understanding of how to write and simulate your program. You'll be expected to do so for your project, so it's important that you practice it with the lab. I do reserve the right to drop a student if the student consistently be absent or not submitting any kind of work. But if anyone wants to drop the course, please be mindful of the timeline, and all of that is on your EduNav, Web Advisor, and everywhere on the website as well for academic calendar. So make sure that we look at the timeline if you decide to drop, so that doesn't impact, you know, could be financial aid because of the W's or your overall grade. Okay. For behavior issues, any kind of conflict, offensive feeling, or disruption, I use the college policy. So that can also be reported to the deans and administration. But please make sure that you address any kind of issues with me, or if I identify the problem, I will address it with you. I follow the zero tolerance for cheating policy. I do read your code. And so do not copy and paste someone else's code. You can look at it as a reference, and we will look at that. There are times that we will take a look at some of the example. However, make sure that we do our own work. It's important that you devote your time to do that because it's your education. And so under cheating policy, anytime that a student is caught cheating, it's a 0 for our assignment. I do report that to the student services area. And that can result in other things like advising, documenting in your files, and so on. So make sure that we write our own program, we do our own work. For accessibility, if you need accommodation, please make sure that you contact the SPS. And also you can visit the library. And this is for MVC. So if you require accessibility at your college, they can send me a letter. And what I will do is I will take that letter and accommodate you. So something like extended time for exam, things like that. And if that helps you, I will be happy to help you with accommodation. For communication, you can access my office hours or contact me via Zoom. Contact me via email. So here's my email address. I am very responsive in email as I already work with some of you to get your ad code. I do answer my phone when I'm in my office. The best way to reach me is via email. Okay. And if you like to get some help or have questions, so let's say down the line that you want me to take a look at the draft of your project, I'll be happy to do that. You can send it via email or you can pop into office hours. I'm on campus Monday through Thursday. Friday, I am on campus and sometimes for meetings and other things or events that I do. So Monday, Wednesday, it's going to be 12 to 2. I know your syllabus might say 1. And this is my office. It's at Moreno Valley College. And so if you want to meet on Zoom, there's Zoom information. Okay, passcode is the same as your Zoom passcode now. And then on Tuesday, 1 to 2. Thursday, 3 to 5. And if you like to make an appointment, I can check my calendar and we can set up something. So let's say if you want to meet on Friday or another time, we can do that. Okay. Any questions? Okay, no questions. All right, so next what we're going to do is I'm going to come back to here. We're going to talk about your unit 1. Actually, before that, let's talk about some resources. So if you need Microsoft Office for assignments, to type up your lab, etc., you can access that. You do have 2-year license. I put a link there. You can also find a link on the left side, the tab of your Canvas. Now for LC3, I put some resources here. So in this class, starting next week, we're going to simulate our program. Okay. And if you have a Windows PC, you can download your simulator using this link. It's a very light download. So once you download, you have an executable. Okay. So let me show you how that is. And I will go over this again starting next week. So once you click that link to obtain the simulator, you are going to see this. So if you have Windows PC, you're going to download using this link where it says simulator Windows version. You're going to click that. It's going to come down as an exe, as you can see here, and you simply open it and install it. You don't need to buy one. You shouldn't have to buy anything for this class. Okay, that's a lot of my classes. I try to use, available resources. So you shouldn't have to buy anything. All right. So when you install, right, it's gonna put an LC3 folder. Okay. So sorry, let me go through and open this for you. So it's gonna look like this, right? And we have to unzip it in order to access the application file. Okay. And if you can't find it, you go to your downloads folder and then you just click on the exe. It's going to ask you to unzip. Okay. Now it's going to say that 12 files is unzipped successfully. You notice that this is the path for the simulator. It's going to put it on your C drive. So there's a folder called LC3, and that's where the simulator is going to exist. So after I unzip, I'm going to go to this PC and go to my C drive, and there's my LC3. Now you can copy this and put it on your desktop. You can put it in your folder. You can put it in your flash drive. However, but when you unzip it, it's going to be on your C drive. Okay. And we're going to use the editor to write our code and the simulate to simulate our code. Okay. And we'll talk more. I'll do this again next week. So that's for the Windows people, right? And I know that all of you might not have all the same system, right? We are going to talk about how we're going to be able to simulate for Mac OS. Yeah. So there is Unix version. Now, keep in mind that they wrote this for Unix. So your Linux, right? It says that Unix tools can be compiled for the variety of Unix platform. So if you're using Fedora, right? So you can install it. I haven't tried installing it on Fedora. I normally use Debian. Like I would use Ubuntu or Kali because of my security classes. So you can use the simulator that's Unix based here. Now, if let's say that you can't, right? What can you do? Sorry, let me go back to my page here. So I put some tutorial videos so you can see how that's done. There are a few people that put the simulator online. So let's say that you have a Mac and you want to simulate the program. Look at this page. It's called LC3 Resources. And on the bottom, I put the simulator, online simulator. You can use this on a Windows PC as well. So when you open it, it's going to look like this. It's going to look similar to your regular LC3 simulator. On the left, as you can see, these are your addresses. Okay. The output is going to be on your console. And then you're going to be able to use this to run. And we're going to write the program using the online simulator. So we'll touch more on this when we start doing the lab with the programming. Other questions? Okay, the registers are on top here. So that's one option. Another option is here. Looks kind of similar, right? Because basically they use the same code. So this one, you know, there are some tools additional, but you get the point in that you don't have to use the install simulator. I'm going to demo everything on the regular simulator that you download and install as I'm using Windows 11. I have a PC, so, but you can use online simulator. And I hope I addressed the question that you had earlier. Okay, so we'll talk about instruction like and, not, add, and all of those later on, so you can come back to that. I did put this PDF file. It's pretty good. You can take a look at how you would use instruction. So we will refer to some of it later on, but if you want to check it out, you can also download it. Okay. So this class, the resources should be free. And then there's some resources for ARM if you're interested in expanding your knowledge with ARM after or during this class. So you can take a look at how you can become an ARM developer. So ARM is used for architecture that's in your smartphone, like your Android for Snapdragon, even on some of the Apple chip. So we'll touch on that. And there are a lot of jobs for that too. Let's say you want to work for Qualcomm or companies that produce chip for, smart systems. You can do that. Any questions regarding simulator or resources? Okay, so one thing about my courses is that it's important that you read, of course, but you can also download your notes or view it. Notes are designed to help you with your assignments, right? And in this course, it's pulling from a lot of different resources. So in my lecture, I normally refer to my notes, and sometimes I would refer to the PowerPoint. Sometimes I would take some of the content from the PowerPoint and I put it on one document so it's easy. So you can download the notes. And when you prepare for your quiz, you can take a look at your notes and your assignments that will help you preparing for your quiz. Okay. All right, so we're gonna go to the next part. So I'll post the link to your videos. So now what we're gonna do is we are going to go over our assignment together. So if you want to download that and open it up. Let me come back to here real quick. So first, we're going to talk about binary and hexadecimal so you know how to convert. And if you already took my CIS11 class, some of this is review for you. There's some additional content compared to CIS7. So I start both the classes to make sure that my student understand how to use number system. And in discrete, that's also important. And this class, binary and hexadecimal, are very, very important. So the number that we learned since we started to talk or when our parents taught us how to count, that's considered a base 10 or a decimal system, because we would have an increment of 10. So you would count from 0, right, through 9, and then you start again in the next group of 10. And that's what we learn when we start learning math, right? When you're taking calculus now, or you're taking trigonometry, right? That's your decimal system. So that's a base 10. And normally when people write this, sometime that they would denote, right, a small 10 underneath the number. So that shows you that's a number system that they're using. But the computer understands binary. So when we open up our calculator and we type in a number and we want to add or subtract or divide, it takes that number and it converts it to a base 2 number system. Because the system, right, your computer or your smartphone or your devices is embedded system, right? It uses logic 0 and 1s. So 1 is when it's on, 0 is when it's off. So when you have a 1 in the binary system, the board or the processor actually receive 5 volts. And that's considered a high value. So if those of you who learn Arduino or microcontrollers, right, programming an embedded system like Raspberry Pi, sometime that in your code you would put high, and it understands that as a 5 volts or a 1. When it receives a 0, or when that bit is turned to 0, that means off, it reduced the 5 volts down to 0 volts or ground. So when we go from a 1 to a 0, it's going to drop from a 5 volts to a 0 volt. And that's considered a low value. So when we see this in the binary system, it is a discrete voltage level between the ones and the zeros. Okay, so how did they coin the term bits? It's really represent your binary digits. That's what bit represents. So when I'm looking at, let's say, a byte, that will be 8 bits, right? And some of it could be ones, some of it could be 0. So in that sense, your circuits is really seeing only the voltage, or ultimately on the digital format, that will be 0 and 1s. And that's going to come back to your Boolean's value, true or false. So some of you have learned programming in C++, Python, or Java, right? And in those classes, we talked about different data types. So you often see for Boolean values, and that's going to tie into the logic of 0 and 1s. And we'll talk about operators and gates also in this class. So then in the binary representation, you often see that it will be a group, right, of values will be 0 and 1s like this. And what they're going to do is they are going to use a small 2 like this, right? So you would know that that's a base 2 number system. So in C or C++ or Java, right, when you define a variable, you would say int, like let's say I want to name my variable 1. When you declare that type of variable and you assign it a value, let's say I want to say int variable 1 is, with an equal sign, right, 20. That number 20 is a base 10 number. Then your system is going to take that 20 as a base 10 number and convert it to your binary number. And that's what it used to compute. Your processor sees everything in binary. So today, what we're going to do is we are going to learn to convert decimal to binary and binary to decimal, along with hexadecimal and octal. So in this example, we see the value 14 in decimal. That's a base 10. How does the computer see 14? So here I put a scale for you. Your scale starting from the right-hand side, the rightmost bit is going to be called the LSB, or the least significant bit. You always want to start from the right-hand side. And as we're working with binary, it is base 2. So it's 2 to the n power. So when I start it from the right, it's going to be 1. It's always going to be 1. And as we move left, we're going to have it multiple by 2 because it's base 2. We're going from a decimal to a binary. So we are using a binary system, so it is multiple of 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and so on. So in a byte, starting from the least significant bit, which is 1, our decimal equivalent starting with 1, going to the left, it's going to be multiple of 2. And in your byte, your most significant bit is going to be 256. Okay. So here we have 8 bits. So with that, when we take the number 14 from base 10, we want to see the equivalent value in binary. So you are going to look at the scale, which is multiple of 2, and you ask yourself, what is the highest number that I can subtract from 14? I cannot subtract 16, that's too large. So 8 will be the highest number that I can subtract. So I take 14, subtract 8. And as you subtract that number, you need to put a 1 on top of it. So that bit turns on. This will be like 0, right? Because it's too large. So as I subtract 8, I put a 1 on the top. And so that means that I'm left with 6. 14 minus 8 is 6. Then I look at the scale again. What's left here? What other number I can subtract from? I can subtract 6 from, right? So I know that that's 4. So I would take 6 minus 4. And as I subtract it, I put a 1 at the top. So I'm left with 2. Then I take 2, and I know the next number I can subtract is 2. So 2 minus 2. So as I subtract, I put a 1 at the top. And that will give me 0 left. So as it looks at number 14 in a base 10, it's going to convert it to 1110 in binary. Okay, so now let's do this together. So I would have the 149 in base 10. And again, I would look at the decimal scale, right? Starting from the right, it's 1 multiplied by 2, 2, 4, 8, and so on. I ask myself, what's the highest number I can subtract from? So I know that I cannot subtract 256, so that will be a 0, right? 149, I can subtract the next number because it's less than 149. So 149 subtract 128. And as I subtract it, I need to put a 1 at the top. So you can type that out. Now, if you handwrite your assignment, that's okay, right? As long as I can read it, that's fine too, okay? So 149 subtract 128, 128 from the scale, I'm left with 21. 21 is less than 64, so put a 0.
A lot of people open this shit.
Excuse me? Then 21, right? What's next is I cannot subtract 32, so I put a 0. And so I know that the next number I can subtract from is 21 minus 16. So I put a 1 at the top and I'm left with 5. And you are going to subtract until you have nothing left. So you go down the line, 8 is larger than 5. So I put a 0. 5, I can subtract 4, which is the next number here. So 5 minus 4. So as I subtract, I put a 1 at the top. I'm left with 1. One is less than 2, so I cannot subtract it. I put a 0. And then 1 minus 1 is going to be nothing left. So as I subtract 1, I put a 1. So the answer for number 1, 149 base 10 is going to be, and you write out your values from what you had placed at the top. So it's going to be 0, 1, 0, 0, 1, 0, 1, 0, 1. And so here it is. And we want to put a base 2. And you can find that if you're using Microsoft Word, right? Your subscript is there. So for the quiz and the final exam, I expect that you know how to convert and you will not have programming calculator to do that. And I'll show you how you can use programming calculator to check your answer. Any question? So this is a subtraction method to really simplify the process. You look at your decimal value and you're gonna use your scale, which is multiple of 2 starting from the right. And you're gonna go down that scale and you're gonna identify the largest number you can subtract from. Anything that's remained, you're gonna keep subtracting until you have nothing is left. And as you subtract, for that individual bit, you put a 1 and that bit is turned on. If you cannot subtract, put a 0, and that's how you're able to convert decimal to binary. Any question? Okay, so we're gonna do 1B. So here we have 307. And 307, again, we're gonna look at our scale. So at first, I'm gonna identify what's the highest number I can subtract from the multiple of 2 scale, or 2 to the n. So I know that 307, I can subtract 256. So I would put a 1 on top of that. And as I subtract, I'm left with 51. I cannot subtract 128, that's too high, so put a 0. I cannot subtract 64, that's too high, put a 0. I know that the next number, 32, is less than 51. So I would take 51, subtract 32, and as I subtract it, I put a 1 at the top. So that bit is on. So 51 subtract 32, I'm left with 19. Then the next number on this scale is 16. It's less than 19, I can subtract. So 19 minus 16, I'm left with 3. And as you subtract, don't forget to put a 1. So 3, I'm going to continue to subtract. So I cannot subtract 8. I put a 0. 8 is too high. I'm only left with 3. Then next, 4, still too high. So I put a 0. But I know that 3, I can subtract 2. So 3 minus 2, I have 1 left. So as I subtract, I put a 1 on the top. And then as I'm left with 1, I can subtract the last number on the scale, which is 1. 1 minus 1 is 0. I have nothing left. So as I subtract, I put a 1 at the top. So the 307, which is a base 10, it's equivalent to 100110011. Now, we have calculator to check this, right? But we need to know this because in your simulator, you're going to see 1s and 0s. And you need to know what it represents. As you move through the program, you need to see what the computer is storing, what the processor is seeing, or what the result that you get. Because at the low level, you're not going to have any text output. We are going to see hexadecimal and binary. And this is why we're spending the time to do this. Any question? Now, there are other ways to do this using division method, right? But this is one way. And I found that throughout my 18 years of teaching, this is the easiest approach. As we know how to add and subtract, easy. Question? Okay, so for C, I need you to do that on your own, right? Check your scale here. Look at the number that you can subtract. So maybe 32. And then the remainder, so as you subtract, put a 1. take the remainder, subtract the next number that you can. If you cannot, put a 0, and you should be able to get your result. So put your steps and your answer there.
I do have a question. So
Yes,
in the beginning, do you need those zeros before the 32?
you
Or
can
can you
put
start with
it,
the 1, 1?
right? So we, if it's easy for you, put the 0. Now the calculator or the computer, sometime when it display it, it omits the 0, right? Because it's basically null, no volts. But yeah, you can put it if you wish. Okay,
So we don't have to though, is what you're saying?
yeah. Normally, a lot of time I recommend that putting the 0 to represent that complete byte. But when your system display it, it really doesn't put the 0 in the front. That's just extra for it, so it doesn't, right? So you don't have to.
Okay.
Mhm. Good question. Other questions? Okay. Now, how can I check my answer? Okay. If you're using calculator, and again, I'm using Windows PC. So if you're using a Mac, you can find out. I'm not familiar if Mac has a programmer mode. I'm pretty sure it does, right? But there's also app on your smartphone to have your programmer calculator. So your calculator has different mode, right? Normally you see the standard mode. Some of you would use scientific mode for your classes, your math classes. Right, so I can choose different mode here. I can also use graphing calculator, right? But to check your answer for this class or even discrete class, you can use your programmer mode. So I simply click this, which is for your navigation, and then I choose programmer. So it's going to look like this. Now, if I'm using a decimal number, I would select DEC for decimal. So, and normally it's selected for you by default. So I would punch in 307 in decimal. And you notice, see how it shows you the binary here? So when you click it, right? So the earlier question was, should I put the 0 in the front? As you can see that. Now, the reason why you see this is because I'm choosing how it represents the data. So this is quad word, right? Remember that the word size for Microsoft or for Windows is going to be, or your Intel system is going to be 16-bit. Some system is 64-bit. So that means that it's 4 times 16, right? Which is 64. Now, if I reduce this to 32-bit, which is a double word, right? It's still the same, but if I keep going lower and lower, see how it's omitted? So in representation of a byte, it's only going to show you the 8-bit as the output. Okay. So when you check, just make sure that how you want to display your values, because sometimes if we have a very large number, we want to display our value in more than a byte or more than a word, right? Like a quad word or a double word or a word. So if you choose a byte, and if there are more binary values, it's going to cut it off, because basically it's just doing what you're telling it to do. It's only showing a certain size of your value. Any question? And with this, you have an option to use hexadecimal and octal. Now, on the exam, I only enable regular calculator. You're not going to have programmer mode. So this is just for practice purpose, right? Questions? Okay, so I'm going to flip back to our notes. Next, we're going to talk about how we're going to go in reverse. That means that we are going to go from binary to decimal. And as we subtract, going from decimal to binary, now the opposite way, when going from binary to decimal, we are going to add. So let's say that you're given a binary value like this, 0, 1, 1, 0, 1, 1, 0. And you have to find its decimal equivalent. So you can use the scale again. It is multiple of 2 because it's binary, right? So your decimal equivalent is going to be multiple of 2 starting from the least significant bit on the right-hand side. 1, 2, 4, 8, 16, and so on. Then you place the binary value on top. Then what you're going to do is you're going to identify the bits that have the ones on top and the decimal equivalent. So I know that the second bit, which is 2, that's on. And that's significant because we want to be able to sum up all the bits that are on. So I know that the second bit, so that will be 2. I take 2. I'm going to add it to the next bit because that one is also on, 4. And then it's going to skip 8. 8 is off. So after that, we're going to add 16. That bit is on. And the one next to it, 32. We don't have to worry about the rest because they're 0. So as you sum that up, 2 plus 4 plus 16 plus 32, you're going to get 54. So that binary value is going to be equivalent to 54 base 10 number or decimal. Okay. All right. Now we're going to come back to our assignment. For number 2, right, we talked about the example. We're going to go to then D. We want to convert 10111101 to a decimal. So the first step is to use the scale and place the binary value on top. That's the reason why I put the scale for you, so it's easy for you to see your decimal equivalent. We're going to identify the bits that have the 1 on top. So I know that 1, right, that one is on. I highlighted that for you. It's going to skip the second bit to it's off, so we don't worry about that. We're going to add it with 4. So 1 plus 4 because that bit is on. Look at the next bit. 8 is also on, so we plus 8. The next bit, 16, it's also on. We're going to plus 16. Again, 32, that one is on. It's going to skip 64, that bit is off, so don't worry about that. Then we're going to add 128. That one is on. So as we sum that up, we would have 189 base 10 or decimal number. So when we're going in reverse from a binary to a decimal value, we simply use the scale, place your binary value on top, identify which bit that is on or has a 1. The decimal equivalent value is going to be added if it has a 1 or the bit is on. And so when you sum that up, you would have the decimal equivalent. And yes, you can use your calculator to check your work. Any question? For E, you will need to do that. So we would have this binary value, place it on top of the scale that's provided. Okay. Now, let's say for quiz and exam, you don't know, right? You don't have the scale, then you think about, oh, starting from the right, that's 1 times 2, and you just multiply by 2 each time. So you have your own scale there because it's 2 to the nth power for binary equivalent or decimal equivalent to binary, I meant. So take this binary value, place it on top of your scale, find the bit that has the 1 on the top, and then add the decimal equivalent that has the bit 1 on top. So once you have the sum, you have your answer. Okay. And then we would do the same thing for F. So I did do G, so I will go over G. I have a chat question. What does the 10 mean next to 189? That means it is a base 10 number system or a decimal number system. Our regular counting number. Okay. The little 2 represent binary. The little 10 represent decimal. The little 16 next to the number represent hexadecimal. The little 8 represent octal. So that simply just represent the type of number system that we're using. Now textbooks, you know, most textbook, they would use the base. Sometimes they don't. But when you see 0 and 1s like this, you know it's binary. Okay, other questions? All right, let's do G. So I'm given this value in binary 0, 0, 0, 1, 0, 1, 1, 0. And I want to make this convert it into a decimal. Again, I'm using that scale that is multiple of 2, starting from the right, 1 times 2, 2 times 2, and so on. Then I place my binary value on the top. And then I identify the bits that have the 1s or the bits that are on. And I would use its decimal equivalent or the scale value, and I add them up. So I take 2, add it with 4, add it with 16, I have 22. So this binary value is equivalent to 22 in decimal or base 10 number.
I had a question.
Sure.
For this one for 22, is it necessary to put 0 where the decimal 256 is, or does it not matter?
It doesn't matter. You can. Sometimes
Okay.
that helps. Right? So now, like I showed you earlier, the computer, sometimes it omits it when it represents the value or it shows the value, depending on what you choose to display. So if, you know, if it cuts it off, then because you choose it to represent in a certain size or storage size. Okay.
Okay, that makes sense. Thank you.
You're welcome. Other questions? Yeah, for me, sometimes it helps me to visualize the actual byte by filling that in. But if it's empty, it's just null, so 0. No volts.
So putting the X as 0 is just for like human use for just us to understand it.
That's correct. I think a lot of it, so at this point, what I want to show you in this class is what you see and what the compared to what the computer sees. So in this class, we're going to really look into what the computer sees, right? We're going to, all the things that we're going to work on is what we use and interpret it to what the computer uses. And it's important when to really understand the concept, because some of you might go into computer engineering or computer science. You have to really understand how it works at the low level to really build an effective program at a high level.
So does the computer read those leading zeros at all?
It can if you give it, right?
Okay.
So if I give it a quad word or a 64-bit and I tell it that, you know, but if you don't fill it in, it's going to automatically assume that those are null or 0.
Okay.
Because let's think about that, right? Like when we initialize or when we declare variables, sometimes we might give it a very large size. Like for example, we might use long or double in C or C++. But we don't necessarily initialize the value to really fit that size, right? So let's say I'm saying double my price is 2, right? I could use int or 2.00. I could use int, so it doesn't really fill up that actual storage, right? It's going to take a portion of it and it's going to fill, and the rest is going to be 0. And we would see the comparable from high level to low level down the line as well, like how it sees a function, you know, what happens in a stack, and how on the low level, what the stack is like. Okay, next we're going to move on to adding binary. And if I don't get to finish everything in this session, I will carry it over to Thursday. And then we will wrap up, you know, for the week on Thursday. So Thursday, this week is exception in that we're gonna do a little bit more on like assignment exercises compared to coding. Okay, so next we're gonna do adding binary. And here I put a little table. Okay, but if you're using your notes, oh, let me talk about this real quick so that way you know how, and then we'll do the arithmetic. So for those of you who are interested in doing division method, I put down the step for you. So let's say I want to take the decimal value and I want to convert it to a binary. How would I do that? You already saw that we could do subtraction, right? But really in division, it is subtraction multiple times. Okay, so let's say that we have 152 in decimal or base 10. And we want to use division method to find a binary. You would start with taking the decimal and you divide it by 2. Why 2? Because binary is a base 2 number. It's 2 to the nth power. So I take 152 divided by 2. As it is an even number, you're not going to have any remainder. So 152 divided by 2, I have 76. There is no remainder. I put a 0. So that bit is off. Then I'm left with 76, the quotient. I would take 76 divided by 2. As again, it is an even number. I'm not going to have a remainder. So I'm going to have the result as 38. So no remainder, I put a 0. 38, I divided by 2 again. So it is an even number. I'm left with 19 as a result, 0 remainder. Now 19 is an odd number. So 19 divided by 2 again, I know that 2 times 9 is 18 with one remainder, right? So 19 divided by 2, I have 9 as a result and one remainder. So as you have a remainder, you put a 1, that bit is on. Then I take 9 divided by 2 again. I have 4 as a result with one remainder. Put 1 for the bit, that bit is on. 4 divided by 2, I'm left with 2 as a result with 0 remainder because it's an even number. So that bit is off. 2 divided by 2 again. I have 1 as a result with 0 remainder. And then 1 divided by 2, I have to go on, right? You don't stop at 1. You have to divide until you have 0 left. So 1 divided by 2, I have 0 with a 1 remainder. So this is going to represent the binary values that we have. So when you write it, I put down that when you write your binary value, you're going to start from the bottom, the last step. That's going to be on the left. Because the last step is your most significant bit. The first step is your least significant bit. That's the right-hand side. So this one is going to be in the front. The next 0 is next to it. And then on the first step, that's going to be the last binary value. Least significant bit, the last bit on the right. Okay. Any question for division method? So whichever way is easy for you, right? This one you divided by 2, so fairly fast. You can use this method or the subtraction method. So let's talk about addition now, right? The computer adds. Yes, you're dividing by 2 each time, and you divide until you got 0 left. If it has a remainder, that bit is on, you put a 1. If it doesn't, right, then you put a 0. So before we start adding, we need to talk about addition rule for binary. Just like decimal. So let's say I add 9 plus 2, right? What happens is when I add 9 plus 2, I know it's 11, but when we write the 11, it's 1 with the carry 1, right? So we move the 10 to the next column to represent, that's the 10 in the unit, and then the 100 and the 1,000 and so on, because it's our base 10. In binary value, when you have a 0 plus a 0, you have a 0. When you have a 0 plus a 1, you have a 1. A 1 plus a 0, you also have a 1. And a 1 plus a 1, it's a 0 with the carry 1. It's going to carry to the left side. Okay. So as you look at this example, I have 0 plus 1, I have a 1. 0 plus 1, I have a 1. Right? 1 plus 1, it's a 0 with the carry 1. Now, when you do the addition or subtraction in binary, you're going to handle 2, right? The top 2 at a time, 2 at a time. So I'm going to take the carry 1 and I'm going to add it with the top. So a 1 plus a 0 is a 1, right? The result is 1 here. Then I take that 1 plus a 0, I have a 1. Okay, and I'm going to demo this shortly. And then the rest are 0 because 0 plus a 0 is a 0, 0 plus a 0 is a 0. So this is your output. All right, coming back to our assignment now. Okay, so let me turn on my whiteboard real quick. Give me a second. So let's do the next exercise together. Let's do a new whiteboard. I'm gonna go ahead and have this value, right? Let me copy and paste it. So I'm gonna do H with you. Let me line it up real good here. Okay, so we are gonna go from the right-hand side, just like how you add, right? And let me see if I can underline this real quick. It didn't like that. All right. So let's try. Sorry, I just want to make sure it's lined up so it's easy to see. Okay, so starting from the right, we're gonna take this one and we're gonna add it to the bottom. Okay, so a 1 plus a 0, we know that it's gonna be a 1. A 0 plus a 1 is gonna be a 1. A 1 plus a 1 is gonna be a 0 with the 1 carry. Trying to write it here. Okay, now with the 1 carry. I don't know why it's doing that on my screen. All right, so a 1, now you're gonna do this, okay? You're gonna take that 1 and you're gonna add it with the top line. So a 1 plus a 1, that's gonna be a 0 with the 1 carry. I'm using a different pen on my laptop, so I apologize if it doesn't come out too well here. Now, next, I'm going to go ahead and take that 0 and I'm going to handle it with the bottom line. Okay, like this part right here. Okay, so a 0 plus a 0 is going to be a 0. Now, next, I have this carry 1. I'm going to work that with the top value. So a 1 plus a 0, that's going to be a 1, right? That right here. Now, the result from 1 from those two, 1 plus a 1 is going to be a 0. So a 0 with the carry. Then again, I'm going to handle the top two. So a 1 plus a 1 is going to be a 0 with the carry. A 0 plus a 1 is going to be a 1. Again, we're going to add the top. So 1 plus a 0 is going to be a 1. Take that 1, add it with the bottom. 1 plus 1 is a 0 with the carry. Now, again, we're going to take that 1 plus a 1, right? Is going to be a 0 with the carry. The 0 plus a 1 is a 1. Now, you ask me, well, what happens to this 1 that's hanging out in the front? We know that it would be a 0, right? Because it just fills in all the 0 in the front. So a 1 plus a 0 is a 1. So this is your answer. So 1, 1, 0, 1, 0, 0, 0, 1, 1. Sorry, my new pen is not cooperating as best as it could, and then you can put a base too. I'll do the next one with you. Any question on this? And there are tutorial videos on YouTube. I put some links there for you, but you know, and if you watch my video also from prior semester, I do the same thing like this. The best approach in this is when you carry, you just place it on top on the left column from where you are, and you're gonna handle 2 numbers at a time, the top and the one below it. Yes, you have a question? Tiara? Okay, I'm not able to hear you. I don't know if there's a microphone or...
I actually had a question.
Sure.
Does subtraction gonna be like the similar process, or does that have different rules as well?
Similar. Yeah, subtraction, pretty much the same approach. Is you're gonna handle two numbers at a time.
Okay.
I'll go over that too. All right. So if you want to wait, we can talk about your questions in a little bit. Next. Okay. At the end, you just add the 0 to add the digit. Yes. That's okay. You can type it or you can unmute and ask. I don't know if your microphone is working. Okay, so let's see. With addition and binary, there were numbers under about the notes. With the addition binary, there were numbers under. The answer. Oh, okay. So when you're looking at the notes, right, this right here represent the bit position. Okay, this is bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, bit 9, bit 10. That just represent the position of the bit. And this is the least significant bit on the right? So this is just telling you like which bit it is. So if I'm saying bit 0, it's bit 0 is on, right? That's 1. If I'm saying bit 5, it's 0, it's off. If I'm saying bit 8, it's off, right? 0, no, nothing there. Bit 3, that one's on. Okay. Yeah, you can do that too. You can, if you have a whiteboard, you can use your whiteboard. Some of you are using your iPad for the class. You can, you know, do that too. All right, screenshot. As long as I can read your answer, it's fine. Okay, so next, let's do the next one together. Sorry, I have the notes. Okay. So we're going to do this one together so you're more comfortable with it. Let me see if I can. Let me clear out my whiteboard. a chat question. Okay, you have a MacBook. Mac program should have the same options that you can use as for handwrite. Let me see. Let me delete this. Okay, all right. So now let's do the next one together. Some of you might be ahead. Okay, so I need to add this. Let me move this over. Right? And so let's do this together. So let me use blue. It's coming out in multicolor, I guess. All right. So let's start from the right. We are going to start with 1 plus 1. 1 plus 1 is a 0 with the carry 1. Now we talked about handling the top and the top and the carry number. So we're gonna start with this next. So 1 plus 1 is a 0 with the carry. A 0 plus a 0 is a 0. Next, I'm gonna switch pen. 1 plus a 1, the carry and the top. I'm gonna work on that together. Now 1 plus a 1 is a 0 with the carry. Now we're going to take the result from the top two. We're going to add it to the bottom now. So 0 plus a 1, that's going to be a 1. Okay. And that's this part right here. Then next, we're going to go the carry in the top number. That's a 1, right? 1 plus a 0 is a 1. Then I take that 1 and add it to the bottom. Let me undo that because it's blocking. So 1 plus a 1, it's a 0 with the carry. 1 plus a 1 is a 0 with the carry. 0 plus a 0 is a 0. I draw on my screen too often. Sometimes it's losing. All right, 1 plus a 1 is a 0 with the carry, right? A 0 plus a 0 is a 0. 1 plus a 0 is a 1. Take this 1 and add it to the bottom. So 1 plus a 0 is a 1. Now we have no more carry, so we just add those two in the front together. A 0 plus a 1 is a 1. And that's your answer with the base 2. Okay. Question. So we always bring the carry to the left column and then add that to the top number or top value. And then get the result, take the result, add it to the bottom value, and there you have it. Okay, so that's both of the addition exercises. Make sure we know how to do that for our quiz and exam.
I had a question.
Yes.
Are we going to be able to do this in the LC3?
You don't necessarily have to do it in LC3. What happens in LC3 is you have an instruction called add, right? So let's say that I'm writing a program and I want to take two numbers and add it, right? Like a number 5 and a number 2. On the simulator, when it puts your instruction in certain location, it actually shows what value it is in binary. And the reason why we're doing this is I want you to be able to check it at certain point. Okay. So if
Okay,
I
I see
take
what you're
5
saying.
plus 2, I know it's a 7. So at the end, in a certain register, it should have your result value before, you know, because when you see text, text is actually encoded, right? Either ASCII or UTF-8. In LC3, we're going to work with ASCII. So the number 8 that you see on screen is converted. It's already ASCII converted. So that's going to take a value on the ASCII scale and add it or subtract it. So that way you can see the text character 8 as a value. Okay. So we have to really think about like, oh, the computer see the binary. The binary has to be converted to text, and text is for human. We'll do exercises like that for the lab so you have a better understanding of like, you know, what's going on. Okay. All right, next part. Now what we're gonna do is I'm gonna go to my notes. Okay. Let's talk about subtraction. So now we're gonna subtract value, and we use the same approach. Okay. But we need to look at the subtraction rule. If I have 0 subtract 0, I get a 0. I have 1 subtract 0, I get a 1. Very similar to your decimal. A 1 minus a 1 is a 0. A 0 minus a 1 is a 1 with a borrow 1 because it's less than 1. So when we subtract, we have to borrow a 1 from the left column and subtract it. Okay. So that's the example. Did I give you guys the subtraction? I'm going to do the example before I get into hexadecimal to be clear with you guys. So let's do an example together. I don't want to use just a book example. So let's erase. We can use the same one. And then I want to make the text. Okay, so let's do. So let's say I'm doing this one, 1, 1. Like this, and I'm going to subtract 1, 0, 1, 1, 1. Okay, so 0. So 1. This is a 1. All right. So as we learned that when we subtract 0 with a 1, we have to borrow 1. So we are gonna go. Okay. We're gonna start with this. So 0 minus a 1, right? We know that it's a 1 with the borrow 1. Okay. A 1 minus, so just like when we add, when you borrow 1, you just put it on the left column and you're going to use it with the top line, get the result, take the result, use it with the bottom line. So next, we're going to take this and we're going to subtract. So a 1 minus a 1 is a 0, right? And a 0 minus a 1 is a 1 with the borrow 1. A 1 minus a 1 is a 0 again. And then a 0 minus a 1 is a 1 with a borrow 1. A 1 minus a 1 is a 0. 0 subtract 0 is a 0. Nothing borrow left, right? 1 minus a 1 is a 0. Okay. Question. Okay, so we see the example. Make sure we know how to subtract. So practice. Let's talk about hex. So hexadecimal converted to binary. So some values are in hex, and hex is used for memory addresses. It's used for if you do like coding, like HTML coding, you would see that hex value is used to represent, or we can use hex value for colors and things like that. So for the color coding, okay. So hex is used in addresses, not just memory addresses. For my security and IT students, they see hex in system addresses, like, you know, your version 6, IP address, your MAC addresses. So it's a way that we can take a number system to represent a physical location or a virtual based type of value for a certain things like addresses. So in memory, we would use hexadecimal. And the reason why I'm showing you hex is sometimes you would need to know like where it is in the memory. If you ever program in C++, so when I teach CIS11, sometimes we do recursive function. And in recursive function, sometimes it cannot produce the result fast enough because it's a function calling itself. So instead of giving you the output of a value, it might show an address, and it's a string of number. And that number is in hexadecimal value. It's just telling you that that's where the result would be, but it's not able to display it to you right now. It stores it, or it would be the location where you can find the data. So sometimes you would see that in your compiler or output, your console, okay? So when we are working with hexadecimal, let's see here. Okay, I'll go over the multiplication stuff later. When we're working with hexadecimal, it is base 16. There are 16 values in the hexadecimal system. Your value equivalents are 0 through 9. It's the same as decimal. So if I have a 0 in hex, it's equal to 0 in decimal. If I have a 7 in hex, it's equal to 7 in decimal. Now, when you have a 10 in hexadecimal, in decimal, like our number, our counting number 10 is going to be equal to A in hexadecimal. Okay. So we know that A is going to be 10. I'm going to draw on here. So let me see. Let me use a new whiteboard. So I know that 0 through 9 is going to be the same. And when you have a 10, that's going to be A. So 10 in decimal is going to be A in hex. 11 is going to be B. 12 is going to be C. Right? 13 is going to be D. 14 is going to be E. And then 15 is going to be F. Screen's driving me crazy. And then 16 is nothing. It stops at F. Okay? Because 0 through 15, you have 16 numbers in that system. So when you see a hex value that's like 4A, right? That's going to be 4 is the same as your decimal, and that's a 10 in decimal. Okay. All right. So with that, what we're gonna do is the next one. So when we convert hexadecimal to a binary, we are going to take the value and we're gonna group it into 4. Because 4 bits represents a hex value. And we're gonna start from the most right because that's the least significant bit. We're gonna group them into 4s as a result for your binary digits. So this example, I have 4E. And we know that it is a hex value because it's base 16. So first, I'm going to take the 4. And I want to take that 4 because it's equivalent to 4 in decimal. I want to convert it to binary. Remember earlier, we would take 4 and we subtract the scale, right? So I cannot subtract so I want to go down, I would take the 4, I can subtract 4, so that's why it's a 1. Okay, so it's 0, 1, 0, 0. Okay, like this. So I have 4E. And so this 4, right, I'm going to take 4. I know it's 1, 2, 4, and 8, right, for now. I know that I can subtract 4, so it's a 1, and the rest is going to be 0. Right? And then the E, earlier I told you that A is 10, 11 is B, 12 is C, right? D is going to be 13 and E is going to be 14. So we know that E is equal to 14 in decimal. So 14. So we start with the scale again, 1, 2, 4, 8, right? So I know 14, I can subtract 8. So 14 minus 8 leaves me 6. 6 subtract 4 leaves me 2. 2 subtract 2 leave me 0. So your binary is going to be 0, 1, 0, 0. And then this next digit, which is 1, 1, 1, 0. Okay, so this is the binary, this is the hex. Okay, they are equal. All right, so now let's do the next one. We are going to go ahead and convert 4B, 1C. This is a hexadecimal, base 16. And we want to make this into a binary. So you're going to take each of the digit in hex and you're going to break it up into 4 bits. So as I explained earlier in the example, the 4, if you go down the scale and you subtract, you're going to have 0, 1, 0, 0, right? B is going to be 11 in decimal. And when we convert that to binary, that's going to be 1, 0, 1, 1, because I can take 11, I can subtract 8, that leaves me 3. I skip 4, which is this one, right? So I subtract 8, I have the 1. That leaves me 3. I skip the 4. 3 subtract 2, I have another 1. And then 1 subtract 1, I have that last bit on. So it's 1, 0, 1, 1 for 11. The 1, when we convert 1 into the binary, again, 4 bits. So I would have 1 subtract 1, only that bit is on. The rest of the 4 bits is off. So whenever you deal with hex to binary, each digit is 4 bits in binary, okay? Then I know C is going to be 12, right? In decimal, which is equivalent to 1100 in binary. So as we subtract, we would have 8 and 4. So those bits are on and the rest are off. So when we combine, we start with the 4. That's going to be these bits here. So 0, 1, 0, 0 goes first. Then the next digit is going to be B. B is this in binary. So you put that here. And then the 1 here. And then the C, which is 12, equal to this. And that's going to be 1100. So 4B, 1C, and hexadecimal is equal to this value in binary. Question?
So you said each number is 4 bits,
Yes. Each
And why-
hex value is 4 bits.
and why is that?
Because it is a 16 base number, it goes from 0 to 15. And if you look at the equivalents, right? For the 4 bits, it's going to fill up the 0 to 15. If you convert it, when it hits 16, it goes to the 5th bit. Right?
I see what you're
So
saying.
if you're looking at your decimal equivalent scale in binary, it's 1, 2, 4, 8, 16, right? So the 1, the 2, the 4, the 8, that fits into the hex number system, which is 0 to 15. Because once it hits 16, it goes to the 5th bit. So only 4 bits can fit for one hex value. And so 2 hex values is equivalent to what? A byte, right? Because if I look at like this one, that's going to fill up a byte because it's this and this. Yeah, we'll work one out. Is there another one? Okay. So for number 2, I'll take this and I'll handwrite it so it's easy for you to see. Sorry, my screen today, I don't know why maybe it's the new pen I'm using. Okay, so let's paste it. Okay, so that's the next question, right? This is gonna be your hex value. Okay. 8, 1, B, D, F. So we're gonna start with 8. And we know that the 8 in hex is equal to 8 in decimal. So I start with my scale. 1, 2, 4, 8, right? That's my 4 bits. So 8 subtract 8 is on, the rest is off because 8 subtract 8 is 0. So this is going to be the 8. Okay. Then the 1, which is this value, right? So 1, I do the scale again. And 1 subtract 1, the rest is 0. So far I have the 8 as 1, 0, 0, 0, right? Then the next value, I already found that, so that's 0, 0, 0, 1, right? Then the next one is B, and B is 11 in decimal, because A is 10, B is 11. So B is 11. So I put the scale again. And you take 11 and you subtract from this line. So 11 minus 8 is going to be 3 left. So as you subtract, you put a 1 on the top. So 3 can't subtract 4. 3 can subtract 2. I get one left, so. So B is 1, 0, 1, 1. Then I have D, right? C is going to be 12, D is going to be 13. Lovely. It's not even, okay, so 13. So D is 13. So I'll put my scale 1, 2, 4, 8. You already know that 8 plus 4 plus 1 is 13. So 1, 1, 0, 1. So you add to that 1, 1, 0, 1. And then we continue to the F. So if D is 13, E is 14, and F is 15. I always remember F is the last one in the hex. So that's going to be 15. Sorry. Okay, so 15 for F. So we know that it's going to be the scale again, 1, 2, 4, and 8. So the question earlier, why is it 4-bit? At the end of this F, right, that's the last value, that's the highest value in hex, which is 15 in decimal. You're going to see that all the bits are on, right? 15 subtract 8, I have 7 left. 7 subtract 4, I have 3 left. 3 subtract 2, I have 1 left. 1 subtract 1, I have 0 left. So you add to this, and sorry, I'm in the next line, 1, 1, 1, 1. And all together, you have this value equivalent in binary. Okay, so the steps are when you take a look at hexadecimal and when you want to go to binary, you take each of the digit in hex and you make it, you convert it by using the binary equivalent as 4 bits. Okay, and we would use the scale because it's binary, it's multiple of 2, starting with the least significant bit 1, 2, 4, 8. You don't go to 16 because at the highest value in hex, which is F fill up all the 4 bits. Okay. So I wrote this down. Now we're gonna go in reverse. Okay. So in number 1, right? I put a little note here because in the prior semester they asked me like, oh, you know, how is that going to be equivalent to a decimal value? The question asks you for decimal value, right? So we cannot just stop at the binary. Once we have the binary value, right? Remember the scale that we had? You put it on that scale and you sum up the bits that have the 1 on the top. So there's an extra step there that you have to do. So once you break it down to the 4 bits each and put it together as a binary value, you take that binary value and you convert it to a decimal, right? Using the scale. So this bit is this bit is on, this bit is on. So I would have 4 plus 8 plus 16 plus 256 plus 512 and so on. So you would add them up, right, to be equivalent to the decimal. And that's how you can go from hexadecimal to a decimal. So the easiest approach is to make it into binary and use addition method to go from binary to decimal. Okay, so that's one approach. I want to show you another approach because I know that we're reaching the end now. So we're going to talk more on Thursday. In addition to this, we're going to do more exercises. So I want you to know well before you start your programming. Any question regarding one? And we're going to talk about two now. Okay, so I put the notes there for you. Convert hex to binary, use addition method to add up the decimal equivalent of the ones. For another way that you see, and it's all over the internet, different approach on how to do the conversion. When you convert hexadecimal to decimal value, you can do it this way. Okay. And I had it also in the notes. Let me unhighlight this so it's easy to see. So let's say that we have the hex value, but what if I don't want to do the binary step? What if I just want to go straight to decimal? So what you do is you take this value, and because it's base 16, right? You are going to start with the least significant bit or the least significant value on the right, which is F. Okay. And F, we know that F is equal to 15. So you would take that 15, because 15 is the decimal equivalent. You're going to multiply it by 16 to the power of 0. Why 16? Because it's hexadecimal, and that's a 16 base number system. So we would take F, we would multiply it by 16 to the 0, because F is on the least significant bits position. Okay. Then you are going to add it with the next value, which is D. And D is equal to 13 in decimal. So you would take 13 times 16 and you would raise it to the power 1, because it is not the least significant. It's next to it, right? It's the next digit. So we would raise it by 1 power. Then we move left again. B is 11 in decimal. So you would take 11, multiply it by 16 to the 2nd power. So as you go left, you're going to increase the exponent by 1, right, with the base 16. And you would multiply it by its decimal equivalent value. So B is 11. I take 11 times 16 to the 2nd power. Then I move left again. It's 1. 1 is equal to 1 in decimal. So I take that and I multiply it by 16 to the 3rd power, because I just moved left. So I'm going to increase the exponent by 1. Then I would go to the next value, which is 8. So 8 is going to multiply it by 16, and I would raise it to the 4th power, because previously it was the 3rd. Now we're going to increase it by 1, so 16 to the 4th. So to make it easy, I put the parentheses so you can see. And so 15 times 16 to the 0, anything to the 0 power is 1. So 15 times 1, I have 15. Then for this one, 13 times 16 to the 1st. So that's going to be 13 times 16, which is 208. Then for the next one, which is the B, 11 times 16 squared, that's going to give me 2,816. This one. Then next one, we're going to take 1 times 16 to the 3rd. So that's going to be 4,096. And then on the next one, 8 times 16 to the 4th, that's going to give you 524,288. And so once we sum everything up, and I didn't write that down, so you would take this value, add it with this value, add it with this value, add it with this value, this, you're going to have the result in decimal. Now we can convert it to binary and then use the scale, just increase it, right? And then sum them up, or we can do it this way. Any question? Okay, so I'm gonna pick this up on Thursday. We're gonna go the opposite way from hexadecimal to decimal. We're gonna talk about division method. And you can take a look at this and you can attempt it. And then so on Thursday, I'm also gonna do another exercise, which is gonna be the lab part for the week. Okay. So we'll pick back up on Thursday on that, because I don't want you to stay past the time, as it is also Valentine's Day. Any question?
I have a question.
Sure, Devin.
For number 1, do you want us to completely solve it or just leave it like that? For
No,
the
you should
hexadecimal?
add it up.
We should add it up.
Yeah, I just leave out some of the ones in the front, so you just check for the equivalent value and then add it up. Give
Okay.
me the result.
All right.
Yeah, I just show it up to here so that way you know what to do. Other questions? Okay, well, thank you very much for a good first day. If you think of a question, you can see me during office hours, or you can send email. Yeah, it takes a little bit for things to be converted. I do have some stuff from the prior semester. Maybe I can set that up. I can link that, right? I have it linked already, so I'll turn that on so you can see and go back and do it until my video is ready, because YouTube takes a little bit to convert 2 hours video. Okay. But when I have the new video, I'll also link it onto the video page. And so where can you find it, right? So once my video is done, I will attach it right here. So you can see it in the assignment itself, or when you look at the module, I always have a video page for each of the week that I record. So I'll turn this one on right now for you to see. Okay. And it's almost the same. There's some stuff from the last class, sometime that it's a little faster or slower. Sometime I finish it at a later point. But you can do that. Okay. It's on the textbook page. So when you go to the module, always use module, click textbook. And then you should be able to have this link. Download. If you're unable to download there, you can also see the syllabus. I think I put the link there, but let me know. I'll check the link. I need you to type your name into the chat for attendance for today. So please put your full name in the chat. Thank you.